So let's get started. So I will start with a few questions. How many people here are already exploring machine learning? And how many people here are already building and deploying machine learning systems in production? Okay. Great. So that will help me to focus on particular areas here. And in this presentation, we will talk about various AI machine learning services and tools, and discuss the best approaches for replacing manual efforts with automation. And we're also going to introduce you to a demo of a typical end-to-end machine learning workflow that uses open source tools such as TensorFlow, Kubeflow, and Keras. So this is about me. I am a CTO of AgileStacks, a cloud automation startup. And we focus on containers and machine learning. We are currently building infrastructure for the autonomous vehicle program with one of the large electronics companies. And I am passionate about Agile, DevOps, cloud automation. So these are all the topics that really excite me. And before we go into the deep of this, let's talk about what is actually machine learning. How is it different from traditional programming? And it will explain us why we are taking the approaches to automate it that we are taking it. So I like this diagram because it shows that in traditional programming, the way how we write our code is we write rules for the software to interpret the data that we send as an input, and it produces the output, right? So it's if-then-else logic pretty much, or rule engines. Still, it's all traditional programming. Now, a new approach has been discovered that is called machine learning, and there we send as much of input data as possible, accurate data, and we send it the results as well. So we send it both input and output, the desired results, and then the machine learning process comes with the rules. It automatically determines what should be the output, what should be the predictions. What's the difference between machine learning and deep learning, right? Machine learning is, sometimes we call it classical machine learning, classical data science. Is that part of this process is that we send as much of input data with answers, with labels as possible, but there is still data scientists involved. They still need to take a look at the data, find features. Features are essentially attributes. Run a lot of experiments in order to find the correlations, and then build the model. And the model is going to then work. It's going to look at the data. Let's say it's an image of a car, and then it'll say it's a car or not a car. So a good example would be, I want to predict whether this person is going to purchase a dog or a cat or a turtle. So I'm going to look at all the data I have, and I'm going to find features. What's the person's age? Do they have children? What is their income? And so on, so forth. And I'll try to find the best correlations that I can. That's going to be my, essentially, feature extraction process. That is machine learning. Now, deep learning is taking it one state further. What happened is that in 2001, a group of scientists from Microsoft, they established that if you take the simple algorithm, it's actually a neural network algorithm that's called persistron, and send it a lot of data, like a huge amount of data, accurate data, that it will find the features automatically, and it will beat the human, it will beat the data scientist in finding these features. And so this is what the way how it works, is that the deep learning process based on convolutional neural networks or similar networks, it will determine features automatically, And that way, it will come up with this miracle that results in accurate predictions. Especially powerful in the area of image classification, video perception, language translation. Pretty much right now, the neural networks are used overwhelmingly in these areas because there's just no competition there. So basically, you use TensorFlow and neural networks if you want to do this kind of scenarios, especially with video. And now let's take a look at all the different choices that we have in order to implement our machine learning, right? So I also organize it by level of the user, starting from a beginner who is a beginner in the data science space, not necessarily a beginner developer, right? But if somebody just has software development experience, but they don't know what machine learning is, then there are a lot of services available in the cloud that will help them to get started. And on Amazon, for example, there are services like Poly, Recognition, Comprehend, Translate, and so on. They will do image recognition for you. They will do translation. You will send them text in English and it will translate it to Spanish, and so on. And you don't have to really understand how it works. You don't have to be an expert on machine learning. You just send it. It's just an API. The cloud provider takes care of it for you. It works great with image recognition. For example, if all you want to do is just read a license plate and basically send it an image of a license plate from a car, and you want that service to tell you what are the numbers in the plate. That's just the perfect service for that. Use AWS recognition for that. Google has similar services. Cloud Vision, natural language, translate. Azure has equally great services for that. Vision, speech, language, knowledge, search. And so that's the first step. What we discover is that this is as easy as it is. It's limited because this is trained for a very specific area. And if you want to get to the next level, you need to be able to train your own model because there is only so much you can do with these services. If you want to tell by the picture whether it's a dog or a cat, that's great, but in practical situation, we want to train the model. And if you want to train the model yourself, then you're going to use a service that helps you to take an existing model and retrain it. It's called transfer learning, where you're already going to take one of the existing trained neural networks and you're going to retrain it. And Amazon SageMaker is a great example of a service like that. It helps you to basically bring your data, bring your model, send your data there, and retrain the model. But this is still limited because for a number of reasons, it has limitations. And so real data scientists, based on my experience, rarely use the services in these two columns. And what real data scientists do, they use expert level services that are either cloud provider specific or they're based on containers and Kubernetes. So Amazon has a number of deep learning AMIs that help you to bring different machine learning frameworks where you have direct control over it, like TensorFlow, like Cafe, others, and then you build your own models, you train them, then you serve them. And that's one way. And then the other way is that you use completely cloud-independent way of doing that. You use containers, Kubernetes. There you run machine learning platforms such as Kubeflow. And then you have a choice of different machine learning frameworks to use. TensorFlow, most popular, but also others like H2O is another one. And the entire cycle of machine learning process looks like this, is that we start with data exploration. We will just look at the data, we will clean it, we will find features, and we'll develop a model using a tool the most common tool for it is Jupyter Hub. It's an IDE for a data scientist. And that's a good starting point. As we established, to build a real model, you need to send it a lot of data. A lot of data means gigabytes, petabytes of data. And there's only so much you can do on Jupyter Hub, on Jupyter Notebook, on a single computer. So you need to take it and deploy it somewhere at scale. And so that's the next step, is that you're going to take your model that you prepared, your algorithm, and then you're going to run it at scale using something like TF Jobs framework. You're going to run it either in a cloud or on-prem, and you're going to build that model. After you build your model, you're going to deploy and serve it, and then you need to serve the requests integrated into your existing application, right? So that's a typical process. The perception right now is that majority of the effort is spent on figuring out what features to use, which framework, machine learning framework do I need to use, whether it's Caffe or whether it is TensorFlow. But in reality, and like this is actually, I quote a famous paper here that a lot of people now quote. It's called Hidden Technical Debt in Machine Learning Systems. So in reality, people who built real machine learning systems and deploy them in production, they shared experience kind of like after they completed that, is that they were surprised how little time they actually spent building the model and building the machine learning code itself. So only a small fraction of real-world machine learning system is composed of ML code. And you see this little small box here. It's called ML. It is ML code. The rest is surrounding infrastructure that is big, complex, and it's all about how do I bring my data, how do I clean it, how do I monitor my model, how do I provide the serving infrastructure. And so the production ML system looks like this. You have a set of features to do data ingestion and validation and analysis. Then you have feature extraction. Then you have a training phase. You need multiple services for model validation, model versioning, distributed training. Then you build your model. You need to integrate it with an application, right? So you need some serving infrastructure. How do I turn that model I created into an API? And then how do I run it at scale? And how do I make sure that, let's say when I recognize a video on my phone, that it's, has a proper latency and everything. So I need entire platform also to deploy it at runtime when I solve typical software scaling problem, right? And so a couple of companies, they came up with various ideas how to create these machine learning systems. Amazon with SageMaker solves some of these problems for you, which is great, although they don't solve the entire problem anyways. And so that's probably the reason why companies still prefer do-it-yourself approach, because they want full control over the entire process of where they do my data ingestion, data analysis, transformation, validation, trainer, model evaluation, serving, logging, and the cycle repeats. So it's similar to like our typical CI/CD pipeline, right? It's continuous process of sending fresh data through the model and retraining it. And so this is what Google did. They created this TFX framework, which is a TensorFlow-based machine learning platform, and they use it internally for their Google Store system, where they do recommendations. Oh, you bought this mobile app? These are the other apps that you might like. This is what they use TFX framework for. They haven't open sourced this framework, but they published a paper about how they did it. But what they also did, they created a Kubeflow framework, which I think is very much inspired by TFX because it also implements these similar steps, how you do data ingestion, how do you do model training, how you do model validation, how do you do serving, monitoring of that model, and run it at scale, right? What we did also, in order to help one of our customers in self-driving space, we created a data preparation workflow where we use an approach similar to SageMaker, but is container-based, and it is completely independent of the framework or the ETL workflow that you want to run. Basically, here on the left, you see the input storage, which is like buckets. You have the code configuration in Docker registry and in Git. And then you have a ML workflow process that is based on Argo, which is open source workflow engine. And what happens is that when you bring your data and put it into the buckets, it will run this, and it will create output files that are going to be your output data processed for machine learning, or it will be your, let's say, a trained model. So the way how it works is that you start with the storage, put some files there in the model. It's a write event, right? It will kick off Argo workflow. Argo will use Kubernetes to schedule containers. And then we're going to run this large number of containers at scale across large number of nodes, probably hundreds of nodes, to process this data as quickly as possible. And this is an approach that we use in order to, for example, clean the data for one of the use cases. And in other use cases, we use it in order to generate a video to train the self-driving car. And so, in summary, building any production-ready machine learning system requires a lot of steps. And there are many tedious processes in the process, especially in data preparation, in data processing stage. That's probably where a lot of machine learning time will be actually spent, about 70%. And everything that should be automated in this area should be automated, And so what we need is that we need to look for machine learning platforms that help us to implement this in a repeatable way and reduce duplication of efforts and hopefully cover the entire workflow of machine learning system, from data ingest to training to serving. That will help you to reuse some of the transformations that you would do, for example, in data preparation and training phase. Use the same transformations when you go into the validation phase. There are many benefits of this, so that's why the companies are building it, and there is a great framework that I would like you to look at, if you would like to learn more. You can look at end-to-end demo of a typical machine learning workflow. I saved the link here. It's just something that helps you to run through financial data on different markets and use it in order to predict whether the US stock market is going to be opening up or down. And the company where I'm working, AgileStacks, we actually have a service to do one-click deployment of Kubernetes and Kubeflow on AWS. We offer a free 30-day trial. So you can use that in order to actually create an environment for this demo, deploy Kubeflow, and then go through all the steps and see how it works in practice. Yeah. And this concludes my talk, so I'm open for questions.